Bonjour à tous, c'est Sylvain Emmanuel et bienvenue à la première session de nos études véhicules électriques. Aujourd'hui, on va commencer avec l'introduction aux véhicules électriques. L'objectif pour aujourd'hui est pour savoir les différences entre les véhicules électriques et véhicules à essence, pourquoi tu dois choisir véhicule électrique et comment fonctionne ce véhicule et les fonctions de quelques composants. Enfin, nous apprenons les taux de charge. Pour commencer, il va faire cette lecture en anglais, mais les mots techniques, je vais expliquer en français. Starting with the operation between fuel vehicle and electric vehicle. Anytime we start the fuel vehicle, energy or electricity is produced by the auxiliary battery to the starter motor. Now, this starter motor, the gear on this starter motor meshes with that of the flywheel, which turns the engine until there is combustion and that energy from the gasoline to mechanical is given to the transmission now to the wheel to move the car. But for the electric vehicle, energy is taken from the battery and step down or step up using the converter, or the converter function or the DC to DC converter function is to step up or step down the voltage to give to the power electronics controller, which sometimes is meshed with the inverter to invert the direct current to alternating current to be given to the electric traction motor, which works in alternating current because most of the electric motors that we have functions in alternating current. Example is the induction motor or the permanent magnetic motor. Although we have the brushless DC motors, but not mostly used in electric vehicle, but for electric bikes. To discuss the pollution, we could know and see that there is a lot of emission and noise from the fuel vehicle due to the combustion and the release of the exhaust, the waste substance or CO2 by the fuel vehicle. But that of the electric bike or electric vehicle, sorry, the electric vehicle, there's less or no emission. It's really silent because there is no combustion. So it's really silent and there's no tailpipe to emit any emissions. Now, looking at the power source or the energy, you could see that it's limited. For an example, the Russia-Ukraine war, since there is a dispute between these two countries, the supply of this substance to the vehicle uses is less. So the fuel prices have gone up. But looking at the electric vehicle, you have unlimited source, either internal electricity by your power distributors. Like for example, we have VRA, Widco, and ECG to do the power distribution. You can also have a renewable source, solar panel, rain power, and you can even use a generator. Now, talking about the difference between these two vehicles, the fuel, buying the fuel or charging, you see that it takes a shorter time to buy a fuel, but with the electric vehicle, it takes longer time. But the good side is there are innovations that are being worked on to make sure that the battery can withstand the charging pressure that we can in the near future have 10 minutes to fully charge your vehicle or 80% of that. Also, another difference between these two vehicles is the energy usage. Now you can look at this as only 25, 12 to 25% of the energy that is taken from the gasoline or the chemical to the mechanical to move this vehicle. Because of during the combustion, there is a lot of energy that's lost to heat. And also with the electric vehicle, 80 to 85% of the energy is used because there is less of moving parts in it. And there is what we call regenerative braking, in which when you deaccelerate, it starts to convert the kinetic energy that was moving the car into electrical energy to just give some power back to the battery, depending on the efficiency the regen has. There is also a backup use. There is no backup use for the fuel vehicle, but the electric vehicle, due to the bidirectional charging, you can use the energy stored in your vehicle or the battery to power some of your phones and your utilities at home. And you have high energy storage. That is one great advantage of fuel vehicle by the electric vehicle. The energy storage is really huge. So if you are talking about the energy stored, the weight is really way better than that of the electric vehicle. Maintenant, il va faire les explications des mots techniques ici. Pour l'opération, les véhicules essence, quand vous démarrez votre véhicule, il y a énergie qui donne le démarreur et le démarreur donne les volants d'énergie qui tourne le moteur ou bien engine jusqu'à on va avoir les combustions et l'énergie se transfère à l'émission. Mais pour les véhicules électriques, on parle d'énergie dans les tractions des batteries au converteur ou bien DC to DC. Mais en français, on dit ça HL. La fonction de cette HL, c'est pour diminuer ou bien augmenter la tension. Et aussi, ici, c'est le contrôleur de puissance électrique. Et enfin, on a les tractions de moteur. Pour la pollution, on a beaucoup d'émissions de gaz et beaucoup de bruit à cause des combustions ici. Mais il y a moins ou aucune émission et c'est très silent. Quand on parle sur l'énergie ou bien source de puissance, on voit que c'est limité. C'est très limité, mais on a beaucoup de sources d'énergie pour les véhicules électriques. On a, on peut dire les énergies renouvelables, éoliennes, solaires, générateurs. Aussi, pour charger, pas un peu de temps pour les véhicules électriques. Ça, c'est des avantages de ça. Mais l'avantage des véhicules à essence, c'est pour acheter le pétrole, il faut moins de temps pour avoir ça. Parce qu'il y a beaucoup euh, de places pour acheter ça. Oui, c'est ça, je pense. Alors, on va continuer avec les meilleures raisons pourquoi tu dois conduire ou bien tu dois choisir un véhicule électrique et pas véhicule à essence. Why should you choose the top reason for you to drive an electric vehicle and not the fuel vehicle? One, because it's cheaper to charge compared to that of you filling your tank. Also, the electricity rates are more stable than that of the gasoline, just as an example I stated, due to the due to the Russia-Ukraine war, gasoline prices have hiked up because there is limited supply of it. But for the electricity, since there is several sources, you can even have your panel which you're going to regulate your charge, and even excess of it can be injected back into the national grid, which they're going to pay for it for you. Also, there are certain incentives in which some governments or nations do give to their citizens because they want to encourage the adoption of electric vehicle, thereby helping in the sustainable development goal 13, which talks about the climate action and also the 7 talks about affordable and clean energy so that the world can limit the global emissions of gases. An example is you buying Hyundai Kona, you have 7,000 and something dollars. Uh, If you buy it in the US, that's free on that. Also, the maintenance cost is really limited due to the less moving parts in this vehicle. There is less maintenance because you don't need to change your spark plugs or your oil filters each and every month. The maintenance on this is really low. Also, you're talking about the pricing, it's quite the same as you buying a full car, but this time around, the cost for you to maintain this vehicle is low and it's cheaper to charge it at the same time helping in the climate fight against global warming. As I said earlier on, since there is no tailpipe, there is no or less emissions in those operations. D'accord. Alors, il va faire des explications, des quelques mots en français. Les coûts pour charger cette véhicule, c'est moins cher que tu vas acheter le pétrole Et le taux d'électricité, c'est le meilleur. Et c'est plus stable aussi. Il n'y a aucune émission de gaz, comme j'ai dit la dernière fois. Et le coût de maintenance, c'est c'est faible aussi quand vous utilisez dans les véhicules électriques. Maintenant, on va commencer pour étudier comment cette véhicule fonctionne et les opérations bien les fonctions de quelques composants. Alors, dans cette partie, on va traiter comment fonctionne ce véhicule, les types de véhicules électriques au monde à partir de ce véhicule et de son opération. Aussi, comment on va charger ce véhicule. Now, how does this vehicle work? When you start your vehicle, energy is taken from the battery pack or the traction battery, which is stepped down or stepped up depending on the auxiliary with what the use is. So let's say you have 300 volts from here and the inverter is a higher voltage, it means you need to step it up through the DC to DC converter. And here we have this inverter. Why do we have an inverter before the electric motor? Because most of the electric motors we use in the electric vehicles functions in the alternating current. So since the battery stores energy in the direct current, it needs to be converted from the DC to AC so that the electric motor can use or can work. Then to be transferred to the transmission, then to the wheels to move it. Now, when you are charging this vehicle, you have an AC source or alternating current, but this battery stores energy in DC. So you need to have a rectifier which convert the alternating current to direct current to power this battery pack. And in the full vehicle, you have the alternator to charge your auxiliary battery. But in electric vehicle, we do not have an alternator. So there is this component which helps in what stepping down this high voltage to a 12-volt voltage to charge this auxiliary battery because starting the vehicle and its lightning depends on this 12 volts. And you can see the power management control. It helps in controlling the power's movement in this vehicle. C'est-à-dire que quand on va charger cette véhicule, la source de tension, c'est alternative. Mais ces batteries stockent l'énergie chimiquement dans direct. C'est-à-dire qu'on doit avoir cette redresseur qui nous aide pour convertir le courant alternatif à courant direct pour charger cette batterie. Et les hacheurs de DC to DC, c'est pour diminuer cette tension pour charger cette batterie. Aussi, on a les onduleurs ici pour convertir les courants directs à courant alternatif qui va aider les moteurs électriques pour fonctionner. Maintenant, on va concentrer sur les types de véhicules électriques. On a, premièrement, we have the plug-in hybrid electric vehicle, the normal hybrid electric vehicle, the battery electric vehicle, and the extended range electric vehicle. The function of the plug-in hybrid electric vehicle or this type is you have a charger gun which you use to top up the little battery you have. Although there is the engine set aside or the car works mostly on the engine, you have an extended range in the battery in case you short fuel. Also, we have the normal hybrid electric vehicle, which runs just on the engine and the battery. But this time around, we do not have a charger to charge this car. And we have the battery electric vehicle. This battery electric vehicle is what is mostly used in the world. It functions solely on batteries. The energy is stored in the battery, we charge it fully. There's no set aside engine with this type of electric vehicle. We have the extended range electric vehicle, which most of the vehicle manufacturers are having. That when you are buying, you have the baseline electric vehicle, you have the extended range vehicle as well. Now we will continue with the inner part of the EV and how they operate. Begin with the charging and the onboard charger, the function of it and how we charge it. So there are several types of charging system or chargers. You have the type 1, type 2 mode 1, mode 2, mode 3, mode 4. You can also have direct or DC chargers and the AC chargers. So today we are going to discuss the role of the onboard charger and the type of charger shown here. So this is a normal socket charger or type 1, which is 3.3 kilowatts, which is a 16 amp charger. So this is the mouth. Um, this is the mouth. So we have your single phase, your earth, your live, and your neutral in here. And this charger, what we call travel charger, because the capacity is really low. And also today we are going to discuss the onboard charger. So an example of an onboard charger is this, which we are going to discuss that in detail. Now, as I said early on, we have the onboard charger. To the function of this onboard charger is to what? Change or convert the alternating current into a direct current. So here you can see the three lines. You have your neutral, the black cable, you have your live, the red cable, also have your earth, red cable, which is converted into what? Direct current. Now direct current just depend on the live, the red color, and the neutral. Okay. So another function of this onboard charger control the current and the voltage which this battery needs to charge. That's taking care of the battery system. So you can see that what the charger offers either constant current or constant voltage, both of which are easy to operate. And each of them has its advantage and disadvantages. In the case of constant current charging, there is high efficiency and charging speed, but there is also a risk that the battery will be overcharged at the later stage and the lifespan reduced drastically. In the case of constant voltage charging, there is a risk that too much current will flow into the battery from the beginning, which will hit the battery too much and shorten the lifespan again. Thus, the charger ensures that it is initially charged with the constant or the onboard charger ensures that it is initially charged with the constant current that's maintaining the speed and efficiency. And when the voltage at both ends of the battery reaches a certain amplitude, it charges to a constant voltage charging. This system is called the charging strategy and is the important function of the onboard charger aside it changing from the alternating current to the direct current. Aside that, we're going to learn how this works using the PSIM. Now, since the function of the onboard charger is to convert the alternating current into direct current, we are going to use PSIM to analyze to know how this works. So we are going to have four diodes in here. So diode 1, diode 2, diode 3. Avec une source de tension alternative ici, ça veut dire qu'on doit avoir une charge à la sortie. Alors, pour visualiser cette tension, c'est-à-dire qu'on doit avoir une tension pour mesurer ça. Aussi, pour mesurer les tensions d'entrée, aussi les tensions de sortie. On doit connecter tout ça par un fil. On doit connecter tout ça par un fil. Désolé, je vais supprimer cette fil. Je vais couper tout ça. OK. Alors maintenant, on peut continuer pour connecter les tensions entre les quatre diodes. On doit connecter tout ça à la masse. Et ici, la terre ici. OK. OK. On va prendre les tensions normales comme 220 et la fréquence 50 Hz. Alors, on va nommer ça c'est tension entrée. On va visualiser ça. Il y a les tensions de ceci. Donc, ça c'est tension de sortie. On va visualiser ça aussi. OK. Ça. Et notre résistance, c'est 10 ohms. On va connecter ça. OK. Bravo. OK. Alors, on fait quoi d'autre? OK. La simulation. On va contrôler cette simulation. OK. L'état total, c'est combien? C'est 0,02. On va prendre 0,02. Pourquoi 0,02? Je vais expliquer tout ici. OK. OK. On sait que la fréquence, la fréquence égale à 1 sur la période. 1 sur la période du soleil. La fréquence égale à 1 sur T, la période. Ça dit que si on cherche l'état, c'est égal à 1 sur la fréquence. Et dans ce cas, notre fréquence c'est combien? 50 Hz. Ça dit que l'état égal à 1 sur 50. Tu l'avais pas donné ça. Ça dit qu'on a 0,02 secondes. C'est ça. À cause de ça, on a notre temps total, c'est 2,02. Maintenant, on va faire les solutions de tension de sortie et tension d'entrée. Alors, ça, c'est les tensions d'entrée. On voit bien c'est cette tension et une tension alternative. Mais les tensions de sortie, c'est quoi? C'est ça. Maintenant, on n'a pas les parties des négatifs. On voit ici 0 jusqu'à pi, c'est positif. Pi jusqu'à 2pi, c'est dans la partie négative. Mais ici, 0 jusqu'à pi, c'est positif. Pi jusqu'à 2pi, c'est aussi positif. Pourquoi ça? Donc maintenant, il va faire une capture de l'écran pour bien expliquer pourquoi maintenant on n'a pas une partie euh, négative, mais tout ça fait partie positive. Ok. Alors, si on a ça, ok, ça, c'est bon. Cette D1, ça c'est D1, D2, ça c'est D3, ça c'est D4. D'accord? Maintenant, D1 et D4, on dit c'est fermé. C'est-à-dire on va remplacer cette diode par une fil, mais cette diode D, D2 et D3 sont ouvertes. Alors, on va avoir ça. C'est-à-dire qu'ils ne fonctionnent pas. Pourquoi D1 et D3, on ne ferme pas toujours les deux ensemble? Si on ferme ça par une fil, c'est en parallèle avec les tensions. Et va secouer cette tension. À cause de ça, on fait, on ferme D1, D4 et D2 et D3. Si on ferme D1, D3, ça veut dire que le courant va passer ici, ici. Ici, c'est fermé, n'est-ce pas? Cette partie, c'est fermé. Ça veut dire qu'il va passer par la charge. Il va ici. Ça veut dire que le positif jusqu'à le négatif. À cause de ça, on a ça ici. De 0 à pi, c'est comme ça. Mais quand on ferme D3 et D2 et on ouvre D1 et D4, la tension va passer ici, dans cette partie, et par la charge, et il passe ici. Le D3 et à la partie positive. C'est-à-dire que c'est l'inverse. Tu vois, c'est l'inverse. C'est négatif jusqu'à positif. À cause de ça, on a toujours ça. Alors, c'est pi jusqu'à 2pi, c'est l'inverse de cette tension. Alors, on va voir ça toujours. À cause de ça, on a cette partie. On voit bien que la fonction principale de notre recherche, c'est pour convertir les tensions alternatives à tensions directement. Ça n'est pas une fonction direct. We know basically the function of the rectifier is to convert this alternating current to a direct current, but you can see here clearly that this is not yet a direct current. So what do we do? We need to add a filter to it, a capacitance. The function of the capacitance is to smoothen the output voltage. Or, comme on va dire, on doit ajouter une tension en parallèle de ça pour, pour lisser les tensions de sortie. Alors, on va ajouter ça. So we add and capacitance parallel to that of the voltage, the output voltage, and check how much you give to the capacitance. So we can now visualize again input voltage, which is still alternating, but when you look at this side, the output voltage, you can see now we have filtered out the ripple and now getting what a direct current. So this is basically how the redresseur works or the rectifier. Now on voit bien que les tensions de sortie maintenant c'est bien lissé. On a bien filtré les effets. Alors on a une tension directe à la sortie. On continue avec les fonctions de batterie. So this battery, the function of it is just to store chemical energy in which the, the vehicle runs on. So the higher the kilowatts are of the battery of the car, the higher the range is going to be. So we are going to look at the composition of these batteries. So you can see from here that the battery that you see in a vehicle comprises of single cells that each can be about 4 volts. So these cells are arranged in a way that it can fit as a module. So the module is what we call a collection of cells connected in series or parallel. So we add them in series to increase us the voltages across them or the total voltage to be increased. Let's say if we have um, this cell to be 4 volts and we have about 5 cells when we connect them in series, that means we increase the total voltages of it to or 20. So 4 times 5 is 20. And if you put them in parallel, it means we are increasing the current we want to achieve or the ampere of the battery. And now this module is added together to form a pack. So the whole pack becomes what the traction battery, which the vehicle is going to run on. Pour avoir la batterie, on doit avoir celui des batteries ici et on ajoute ces batteries en série ou bien en parallèle pour avoir un module. Quand on ajoute les batteries en série, ça dit qu'on augmente la tension totale, mais si on ajoute en parallèle, ça dit qu'on ajoute, on augmente le courant et on ensemble tout ça pour avoir les batteries. So a typical example is this. You can see from here, this is a module of the battery we had on our compound from one of our cars, Charity Blue. So you can see from here, this is the voltage of each module. So some of the voltages of the module was low, so we had to balance charge them to increase or to have a voltage of the same. So you can see here, this is 8.6, but we balance charge 15.7 since most of them were around 15.6, 15.5, 15.7. So the totality of this is what we call a battery pack. So if they say the vehicle runs on a battery pack, so this is the total. When we add each modules together, is what the car runs on. So now we talk about the inverter, the pop or the ondulator, just to convert electric current from what direct current to alternating current. The function they set ondulaire produce convertir a courant direct and courant alternative. I like to explain further in the discussion forum. And also the motor is what powers the wheels. So the electric motor takes power from the inverter because it runs on the alternating current and helps rotate the wheels, in which um, the frequency increases, the velocity increases in this car. That's why they have initial high torques for these vehicles. Also, the drivetrain of this car is a single speed transmission. Most of them are single speed transmission vehicles, except a few which have the sharp pedal to increase the RPMs when they are accelerating or they are driving. Enfin, on va savoir le taux de charge dans cette véhicule. Comment on va calculer ce taux de charge? Il y a des fonctions pour calculer le taux de charge dans cette véhicule. Or, there are two ways to calculate the charge rate in electric vehicle. So the charge rate is the unit battery expert to use to measure the speed at which a battery is fully charged or a battery uh, is discharged. So let's say if we have one formula we have is C equals 1 on T, okay? Or we can have C equals the amp R over the amp, or we can have it to be E over E. That is to say the current or the charge, and this is the weighted energy capacity. So let's say we have an example. You know that 1C equals 1R. Okay. So if you have a battery capacity, we have it to be, let's say, 20 amp hour. Okay, 20 amp hour. The battery capacity of, let's say, an electric bike is 20 amp hour, and we give it a 10 amps. That means we have 10 over 20 amp hour. So now we have 0.5, which talks about what? C over 2, meaning we have 2 hours to charge this vehicle. That is how long it takes for you to charge this electric bike. Okay, which is C over 2, 2 hours to charge this. And now we can talk about the type of chargers we have in this electric vehicle. You can charge your you can charge your vehicle by a standard 3 pin, which I gave an example here, the normal socket. You can also use a type 1 or type 2. Usually we do it with the industrial socket to charge this one. And I can show you an example of using industrial socket. So this is an example of a level 2 type charger. So this is an example of a level 2 type charger in which we use an industrial socket, sorry, an industrial socket for it. You can see a single phase. We have your earth type and neutral in here. It's a mode 2. Yes, it's a mode 2 type of charger we use at home. So this is usually this is a 7 kilowatts um, chargers, and this is a 3.3 kilowatts. And also this is 7.2 kilowatts. And for the AC charging, you can have maximum to be 22 kilowatts, but for the DC charge, you can have about 30 to 200 kilowatts. This is why when you are charging the DC charge, It takes short time for the car to be full because it goes directly to the battery. But we are going to discuss that further on its own. That is going to be a topic on its own. Direct current charging. Just as the AC charging is going to be another topic on its own. We are going to go into details for all this. Now, these are some references and where I took some of the information that I like to acknowledge them. Thank you very much. Merci beaucoup pour votre temps. On se voit. Merci.